Okay, esterification, we are taking, like we're saying, we are going to take alcohol plus the carboxylic acids. We're good, right? Mm-hmm. Right, we are going to put them together. So, the main key, this one they will ask you, the reaction between alcohol and carboxylic acid, they need what we call concentrated sulfuric acid, H2SO4. Concentrated. That word concentrated is needed. Okay, you know how to finish it up. Concentrated sulfuric acid. This is the main one. They like this one here. All right. They say you get a product of what? Water and ester. You good, ne? Mm-hmm. They will ask you the products. They say if we take alcohol, we mix it with carboxylic acid. What are the products? Water and what? Or you can, they say ester plus what? Or name the two products. It's water and ester. All right, so now they say these are used to make perfumes, scent, and flavors. Combination reaction, which involves dehydration. Can you say this reaction is actually a combination reaction? You start with 2, you're gonna end up with 2 still, all right? And then for some little information, the alcohol becomes the alkyl group. So the alcohol, it becomes like the branch. And the acid, can you see the acid? Becomes noate, like methanoate, ethanoate. You did those things, am I right? Mm-hmm. Okay. So I put that in yellow. The yellow one, can you see? The yellow one is the alcohol. Can you see the alcohol is there? Mm-hmm. It's at the end. And then the carboxylic acid, they've got the OH, but with the CO is that part. It's actually the acid, carboxylic acid. Good. Now, when they join these things, I wanna do this so that you can see it yourself. Allow me to use. Let me try to use a light purple. A light purple color. So I wanna write on top of that one, so that you can see how they join, because there is something important, but most teachers, they don't mention it, but you need this, trust me. You need this so much. That's why I put that in color. All right, so what's happening is this, can you see? Do you see both of them, they've got OH, right? Can you see? Mm-hmm. There's a OH in the alcohol, there's a OH in the carboxylic, am I right? Mm-hmm. Those OH are the one which must come together. So I'm gonna turn this one around, though it can be upside down, don't worry. But I want to show you it's the 2 OH that are coming together there, like this. There we go. Now, here's what I want to say, what's important. Now, here's what I'm saying. You need this. If I were to do this, can you see you still have 2 H's, ne? And O. Can you see that? Mm-hmm. Do you see that? Mm-hmm. Or, if I were to do this, you still have 2 H and an O. Can you see that? Mm-hmm. Now the question, which is which? Can you see that? Mm-hmm. Not both of them are right, but they won't show you, the teacher. You'll find yourself doing the wrong one. The correct one is that the alcohol will donate the OH. The acid, actually, you didn't do acid and basis, right?
No.
All right, yeah, I also must. An acid donates H. That's what it does. What is an acid? A substance that gives away the H. Yeah. An alcohol, a substance that gives away the OH. So the correct one is this one, the one that I'm putting in the box. Only one H, not OH, one H comes from the alcohol. You get it? Now, did you notice there was this, the yellow one, ne? There was the purple one, am I right? So now we delete all of these ones. We delete them. And then we draw the bond. Can you see that? The O that you see in the S, because now this is now the S, that this one. All of this is now the S. Can you see that? That O you see is the O that came from the acid. Because when we delete it, it's water, am I right? Then we're supposed to say plus H2O. You see that? There we go. And then we can name it, because I think this name is, there's something wrong with this one. Let's just check, because I kind of checked it here. All right, let's see here. We've got methyl means one. Oh yeah, so can you see this one? Yeah. Why? Which part shows? Okay, let's go back in time. Yeah, at least you already understood what happened there. Let's go back in time and get their name. So this one, you put that in a box. It's like that. So it's only one carbon. Because the box, it's actually the functional group. Can you see that? You can't count that carbon. It's not a carbon that was in the hydrocarbons. You get it? Your hydrocarbons is this one here. So this is one. So that is supposed to be meth. Can you see? Yeah, you're going to call it methanoic. Am I right? Acid. So it's going to be methyl. Can you see that? Can you see? Yeah. And then prop, it's how many? It's 3. 1, 2, 3. Can you see that? Methyl propanoate acid. Now wait a minute. You've got what I call the acid. We're putting the acid and the what? And the alcohol. You see? Acid and alcohol. Acid, I'm not talking about naming them. We put them first. Can you see? Methyl was the acid. A for acid. Can you see? First vowel. AC. AL is far. So with this reaction is a reaction between alcohol, carboxylic acid, the catalyst, it's concentrated sulfuric acid. We good, ne? The acid will donate the H. The alcohol will donate the OH. Am I right? Your product is water and ester. When you name it, that ester, put the acid name first as a methyl, as a alkyl, as if it's a branch. Remember when we're doing branch, we use YL, ne? Yeah, so the acid is like a branch now to you, okay? And then the remaining part, it will have the noate at the end. Is it clear enough for this one? Okay.